This program looks into extraordinary enzymes that, when added to fuel, appear to cut consumption and carbon dioxide emissions by making combustion engines more efficient. Enzymes are harmless protein catalysts that occur naturally in aqueous environments. I'm with Willem Veltevrede, the chief engineer from the Stena trader in the engine control room. Willem, welcome.
Thank you.
How long have the enzymes been used on the auxiliary engines of the Stena trader, please?
It's now for about 1 year.
1 year. And have you had any problems?
No, we have no problems.
No problems. And what change have you measured in terms of measured results in fuel consumption, please?
Fuel consumption is -8%.
-8%. And what change in carbon monoxide output?
This is -22%.
-22?
Yes.
That's quite impressive.
Yes, indeed.
And what change in carbon dioxide, please?
It's -8%.
-8%. And what change in NOx gases, nitrogenous poisonous gas output?
It's -9%.
-9%. With such impressive results, do you think that these enzymes are likely to be used on the rest of the Stena fleet?
This will be a management decision, but they are good results, so hopefully.
Hopefully. I can't say fairer than that.
Yeah.
Thank you, Willem. Thank you very much.
Okay, thank you.
-8% on fuel consumption would save the oil reserves of Russia with approximately 6.3% of the world's oil reserves, according to BP's statistic. During the time it took to research and film this programme, we visited Queen's University Belfast a number of times to report on Professor Douglas's progress collating the data from the sea trials. Firstly, Stena traders' specific fuel consumption analysed over 68 days of the trial.
Yes, we took samples every day of the fuel consumption of the engine, and we plotted a baseline over the first 14 days, so that was full 2 weeks of testing. At that point, X-Mile was added to the fuel and mixed, and then we saw a further almost 30 days before there was any change in the fuel consumption of the engine. So on day 42, we saw something of the order of 10% reduction in the specific fuel consumption, which continued right on through to the end of the test on day 68. But at that point, we were down to about a 15% improvement.
Now we've got another plot of the CO emissions, the carbon output, with again the 70 days of the test.
Yes, this is very interesting because you get a very flat trend in the first sort of 30 odd days, the first month of the test, showing about 1.1 grams per kilowatt hour of CO. Then on day 36, we start to see a phenomena coming in, which we think is engine cleanup, where the CO output increases by about 20%. That continues for 7 or 8 days.
And to be honest, that reflects the experience with motor cars, which I call decoking.
Yes, there's some form of clean-up going on there. But the significance here is that at the end of that clean-up period at day 42, where we saw the huge improvement in specific fuel consumption, the CO then drops back to a level of typically 10 to 15% lower than the original specific CO, which in fact is the same raw CO out of the engine, but the specific values follow the specific fuel consumption.
So a very respectable result from the Stena line field test.
Yes, very pleasing.
Such an extensive trial enabled Professor Douglas to take account of loading in terms of the accuracy of the final results. We've been looking at 500,000 hours of data from multiple shipping, but in particular, the Stena trader, we saw something like a 10% improvement.
But that was at light load condition. Over all of the load, and particularly on some of the other vessels, we've seen that over the full load range, we're achieving an average of about 6 or 7%. So we see 10% at light load and then slightly less at the higher load conditions.
And here we are a year further on.
Yes, on that particular vessel, another 4,000 hours of running. And the great news in that was that over that period we've seen very sustainable results with the 6 or 7% improvement right throughout the full year. So that shows both good durability and sustainability of the particular improvements.
Whereas Stena trialled enzyme-treated marine gas oil, the Teso line in Holland trialled enzyme-treated biodiesel. I'm with Kees de Waal, the director of the Teso shipping company operating between the Texel Island and the mainland of Holland. Good afternoon and welcome, Kees.
Welcome on our ship, sir. It's very nice to have you here today. It's a beautiful day. We have a very attractive island for the people who live there and also for our tourists. And it's very important that we keep it this way for another 100 years, 200 years at least. Therefore, we make use of an addition to our fuel called Soltron XML. And I must say we are happy with the first results. We started using this a few months ago, and we found out that it reduced the use of fuel by 5%.
Now, you've been trying these X-Mile enzymes for how long now?
For a few months now, a few months.
And what sort of results are you getting?
The results we are getting is that we use less fuel, and that's very good. We reduce 5%. That doesn't sound like it's very much, but when we go over this channel for 14,000 times a year, almost 14,000 times, that means that we have about 700 free rides.
700 free rides on the high seas?
700 free rides on the high seas, and that's very good. It saves the environment. It's also interesting for us because it saves money. So it's really a win-win situation.
I think that is a win-win situation. 2 of the Teso ship engines use biodiesel. The other 2 engines use enzyme-treated biodiesel. Monitoring the results on board with us was Dutch government environmental advisor, Mr. Henk Barbet.
The results we've seen so far is an increase in fuel economy of about 5 to 7%. So that also means a decrease in carbon dioxide emissions of the same amount. So 5 to 7%, which is quite considerable.
It is considerable. I mean, what are the implications in terms of the environment?
A ship like this is using an enormous amount of fuel, so even 5 or 7% means it will save hundreds of thousands of liters every year. It also means an enormous amount of less carbon dioxide emissions and other emissions that are connected to the use of this diesel power, such as nitrogen dioxide, nitrogen oxides, and particulate matter. So it's quite a considerable improvement. I think the advantage from an environmental point of view when using heavy fuel oil is even bigger advantages in using an additive like X-Mile.